Yes, Shazil. Why you
Sir,
left the class? Why you left the class?
sir, I had internet problem.
Okay. Now, what are deliquescent salts? Deliquescent salts are those salts that when added to open air, okay, they absorb the moisture. They absorb the moisture and change into their solutions. Like for example, have you seen that during the rainy season, if you kept some sugar or or sodium chloride salt, okay, salt that is in your home, it becomes sticky. It becomes sticky. Sugar, if you kept the open in the open air, okay, in the rainy season, it will absorb the moisture. So why it is absorbing the moisture? Just because they are called deliquescent salt, they will absorb the moisture and will change their statement. They will get dissolved in that. Okay, they will change. They will become sticky. They will become like liquids. Okay, so we'll say that certain substance when exposed to atmosphere absorb moisture and change into solution. Such substances are called deliquescent salts. So note it down: NaCl, KOH, calcium chloride, etc. You noted, Shazil, you are having your camera turned off.
1 second, sir. Done, sir.
Okay. Next, what you need to do here is what are hygroscopic salts, hygroscopic substances? What are hygroscopic substances? So you have seen that what are hygroscopic if I'm talking about that some salts or some substance when they kept in open air they absorb the moisture but they don't change their states. They are good absorbent of moisture. Okay. So they are called hygroscopic salts. A hygroscopic in nature we will say that it is hygroscopic in nature. This salt is hygroscopic. So hygroscopic means it will when you kept it in open air it will absorb the moisture and will make the air dry. Okay. Absorb the moisture will make the air dry and will not change. Like the diffusion salt was changing their state, they are getting dissolved, they become sticky, but they do not become sticky. Okay. So, like noted down, certain substances when absorb moistures when they are kept in the Okay, but do not change their state. They are called hygroscopic salts. Noted, Shazil.
Done, sir.
Next. Now, there are different types of salt that we are going to study. The first salt is caustic soda. Caustic soda is not a salt, but it is a base. But since why we are studying this one in salt, because it is prepared from a salt, is sodium chloride. Okay, so we'll talk about the caustic soda. Caustic soda is sodium hydroxide. And how we'll prepare caustic soda? So you have caustic soda is NaOH. Okay, NaOH. Got it? So when you have NaCl, sodium chloride in aqueous, in water, okay, and you pass electricity to it. On passing electricity, you will notice that this Na, here we have this beaker. Okay, we are having anode and cathode. This one is anode. This one is cathode. This one is anode. Okay, now when we are having NaCl when react with water, we give you Na positive, NaOH plus hydrogen gas plus chlorine gas. What happened actually is that when we add Na, so it will be in the form of Na positive, Cl minus, Na positive, Cl minus, Na positive, Cl minus, Na positive, Cl minus, Na positive, Cl minus. Okay, Cl minus, Cl minus. It is like this. And the water is also in the form of H positive, OH minus, H positive, OH minus, H positive, OH minus. Okay, this is in the form like this. So what happened is that when we have two electrodes, Na, one is anode, another one is cathode. When anode is positively charged, it is positively charged. So you will notice that positively charged on the positively charged, the negatively charged ion will come. Okay. So they are the two negatively charged ion. One is chloride ion, another one is H plus ions. Sorry, OH minus ion. There are two types of negatively charged ion. So they will move, but uh, in terms of losing the electrons, like for example, if you have Na and another one is magnesium. If I ask you that which will lose the electron first? Na and magnesium, which will lose the electron first? Which one is more reactive will lose the electron first? So which one is more reactive? Sodium or magnesium?
Magnesium. No,
Magnesium is
sodium.
more reactive. Sodium is more reactive. So similarly, in terms of gaining of electron, we have a reactivity series like this way. And in that one, we have chloride ion will lose electron first as compared to OH minus. So unless and until there is only a single Cl minus ion there, it will keep on losing the electron. So what happened here is that at anode, what is going to happen? The two Cl minus ion will goes, the two Cl minus ion will go and they will lose two electron and then convert it into Cl2 gas. Okay, what happened? What is the difference between Cl 2 and Cl minus ion. So Cl is having 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Because chlorine has 287 electronic configuration. When it gain one more extra electron, it become Cl minus because of extra electron. So it is having 8. Otherwise, it has 7, 287. So it will have in the outer motion 7 electron, but it has since negative charge, it means it has gained one more electron. So there are two Cl minus ion, they will go and they will lose one electron. When they lose one electron, what would happen? They will become Cl atoms. Cl atoms. Okay, so they will lose one electron and they will become Cl atoms. So one electron from here will be lost, and when it lose one electron, it will lose their charge. Negative charge will be lost. Now they will combine together and form chlorine gas. This is the CFD gas, and those two electrons are there. What happens at cathode? At cathode. Now again, in terms of losing the electron,
Sir, can
sodium
you
is
explain
first.
again?
That's why not. What I'm saying here is that anode at anode, the two Cl minus ion will go. They will lose the electron, will form chlorine gas. Cl2, chlorine ions when lose electron, they'll become Cl atoms. And Cl atoms, when two Cl atoms combine together, they form chlorine gas. And these two electrons, now you know at cathode is negatively charged. Cathode is negatively charged. So the negatively charged, the positively charged ion will go. We have two positively charged ions. One is Na positive, another one is H positive. So sodium is first in losing the electron, but it will be last in gaining the electron. It will be last in gaining the electron. So if an element is first in losing, then it will be last in gaining. So at cathode, they need to gain the electron. So out of this sodium and hydrogen, you see sodium lies here and hydrogen lies here. So sodium is first in losing, but it will be last in gaining. So this will not go for gaining the electron. It will remain as it is. So which will go? H plus ion, because another positive ion is H plus ion in the solution. That is the H plus ion. So it will, the two H plus ion will go there. They will gain these two electrons and will form two hydrogen atom. H plus ion means without an electron. When hydrogen atom lose one of its electron, hydrogen atoms when lose one of its electron, it becomes H positive ion. Now again, it will, when it gain the two H plus ions, when gain one electron, they again become hydrogen atoms. Now they will combine together and form hydrogen gas. Hydrogen gas. So what you are going to study here is that these two electrons will be received by H plus ions and will form H2 gas. Now what about the Na, which is not going ready to gain electron? So Na and OH. Na at in this one, it was left, and here the chloride ion goes for losing the electron, but OH ion will remain as it is. So they do both combine will form NaOH. Or if you are getting stuck here, so it's okay. We'll explain you in the next class. So it will be okay. Okay, don't worry about it. So note it down how it is prepared. So you noted this one, Shadil?
1 second.
And this process is known as chloralkali process. Why this is known as chloralkali process? Because in this chlorine gas and alkali, which is a water soluble base, NaOH is water soluble base, water soluble base. Okay, so this process is known as chloralkali process because the formation of chlorine gas and NaOH, which is an alkali, is formed. Okay, note it down.
Sir, because of chlorine gas.
Yeah, chlorine gas and NaOH, known as chloralkali process.
Done, sir.
You done?
Yes, sir.
Next is this was the explanation for that one, that what happens at anode. At anode, the 2Cl minus ion will form chlorine gas, and there is an oxidation is going to take place at anode. Always the oxidation take place, okay? Because you have -1 oxidation state, it goes to 0. -1 to 0 is reduction. Okay. So it is at cathode. What happens? This two electron, the 2H plus ion will go. They will gain two electrons and form H2. In overall reaction will be this way. Okay, put it down. And you will need to done that whenever we are just taking these reactions, okay, so it should be always concentrated or saturated solution of NaCl should be taken. We were taking these mixtures of NaCl, NaCl and water, so it should be concentrated. If it is dilute, then instead of hydrogen gas and formation of caustic soda, the oxygen gas will be produced. Instead of chlorine gas, oxygen gas will be produced. Okay, if we take the dilute solution, so please note it down. This one first.
I finished.
Okay. We're done.
Yes.
Now, if the questions come for the chemical properties here, that physical properties of NaOH. What are the physical properties of NaOH? You know that NaOH is caustic soda. Okay, caustic soda is just like a. If I show you this one, that caustic soda is just similar to that of like Misri, the crystal, the bigger crystal sugars. Okay, but it is very means it is a strong base. Even if you kept it in, thinking that it is sugar, okay, it will bounce your skin. But that is caustic soda. So let me show you caustic soda. So it is white amorphous solid like this way. Okay, like you can check it. It is just like you went to some hotels. Okay, you find that after sugar we have some bigger crystals of sugar. Means after having. Let me show you here. It is this one. This is like this one. Grass. What this line is this. This is like this is caustic soda. Okay, this is caustic soda. White crystals of but it is very corrosive in nature. Okay, if you kept palm, it will damage your skin. So this is caustic soda. So if I talk about the physical, it is white and translucent, not easily transparent. It is translucent. Melting point is 591 Kelvin. Readily soluble in water means it take time to dissolve. Not readily soluble means it take time. Deliquescent means what do you mean by deliquescent? It absorbs the moisture when it kept in open. It will absorb the moisture and will change its state. Okay, it is good moisture. And when you kept it for long in the atmosphere, it will react with the atmospheric carbon dioxide. Okay, Shazil?
Yes, sir.
It react with the atmospheric carbon dioxide and will form sodium carbonate. It is used in manufacturing soap, detergent, paper, artificial cell, preparation of bauxite. Bauxite is an ore of aluminum. Okay, purification of bauxite and also used for preparation of many compounds such as sodium chlorate. So note it down. This is just it's nothing you need to have for dispute in this. Just it is you need to write it. Note it down.
Done, sir.
Okay, so let's move further. Now the next type of Shazil, the next type of salt that we are going to have is the bleaching powder. Okay, what is bleaching powder? Bleaching powder, have you studied about bleaching powder?
No, sir.
Bleaching powder is used to bleach, means oxidize, or to remove the color of the clothes, paper. Okay, that we call bleaching powder. So bleaching powder, if I talk about bleaching powder is actually calcium oxychloride. What is it? Calcium oxychloride. One marks question coming from here. That what is bleaching powder? It is calcium oxychloride. CaOCl2. Got it?
Yes, sir.
CaO CaOCl2. Calcium oxychloride. That is like Ca. Then we have O, and then Cl, and then Cl. This is the structure. Okay. And what happens here is that how it is prepared. When we have calcium hydroxide, which we call it slag lime. Okay, let's concentrate on slag lime. When you pass, when you have bleaching powder, calcium hydroxide, okay, and sorry, slag lime, and when you pass carbon dioxide to it, sorry, chlorine gas to it, okay, it will become CaOCl2 plus 1. Okay, this is called bleaching powder. So if this is very simple preparation, that slag lime, when pass chlorine gas to it, okay, it will gives you CaOCl2 plus. Got it? Understood?
Yes, sir.
So here the process by which it is prepared is or manufactured is known as Hazen-Clavel process. Like the previous one was, what was the name of the previous process caustic soda?
Chloralkali.
Chlor-alkali. Chlor-alkali
Alkali.
process. Okay. So note it down this one also. The bleaching powder. One marks question come from its chemical name. What is chemical name? Calcium oxychloride or
Calcium,
calcium
calcium hypochlorite.
hypochlorite. Preparation by passing slag lime with the chlorine gas. Okay, when you pass chlorine gas to it, it will give solution.
The process by which bleaching powder is manufactured is called Hassensler.
Hazen Clever, CLEVR, Clever process. Done.
Yes, sir.
Next, what are the properties of this one? It is yellowish color compound. Okay, yellowish colored compound which is having a strong smell of chlorine. Okay, and when exposed to air, it react with the atmospheric carbon dioxide. Okay, got it? So when
Yes.
when we kept it in open air, it reacts with the atmospheric carbon dioxide and CO2 carbon dioxide. This is very simple. That what happens? What would happen here? Let me explain. It is yellowish color compound. When you kept it in open air, this chlorine bleaching powder react with the atmospheric carbon dioxide and will form calcium carbonate. And chlorine gas will be eliminated out. Okay. This will togetherly match together CaO plus CO2. We get CaCO3. And this chlorine gas will be eliminated out. So and this chlorine gas is responsible for bleaching purpose, for the action of chlorine gas. Okay. Got it?
Yes.
So if there is no chlorine gas, there will be no bleaching powder, no properties. So when it reacts in the previous one, also in the previous one, when we have sodium, caustic soda, when you eat kept it in open air for a long time, it react with carbon dioxide, it will form Na2CO3. Here it is forming sodium calcium carbonate. Okay, got
Yes.
it?
Yes, sir.
So you have to keep in mind this. So note this one, that it is yellowish powder. Okay, it is yellowish powder and simply keep which when kept in open air, it react with the atmospheric carbon dioxide and chlorine gas will form. Provide this bleaching powder, we always kept it here, airtight container. Okay, so that it will not react with the atmospheric carbon dioxide. We just kept it in airtight container. Okay, got it? Got it, Shazil? Why have you turned off
Yes.
the
Yes, sir.
Note it down. You done?
No, sir.
Sit down first.
I have to write the reaction with acid. This note, right?
Yeah. Sit down. Done.
No, sir.
We have not done the pH scale. Yes, we
Sorry,
have
sir.
not done. We have not done pH.
No, sir. Fins.
Um, so not only uses of bleaching powder, what are the uses of bleaching powder? Uses of bleaching powder is used as disinfectant, okay, for killing germs in water, not at fast pace. It is chiefly used in bleaching cotton, textile, wood, paper, pulp, etc. It is applied for making wool unshrinkable, okay?
Yes.
It is a strong oxidizing agent. Done?
One second. Done.
Next, what you're doing here is that you know this question, please. This question.
Done. Sir.
Done. Okay. So, Shazil, what's the answer here? What's the answer for this question? A compound X on electrolysis. A compound X on electrolysis in an aqueous solution produces a strong base. This is that compound S on electrolysis gives a strong base.
Calcium oxide.
Now check it in the previous two salt that we have studied. Base Y along the gases A and B. Check the salt that we have studied. A compound X on electrolysis in aqueous give produce a strong base. Check it fast. Name the two salt that we have done earlier. First of all, turn on your camera. Tell me, name the two salts. Name the two salts
Sir, which one?
that we have studied.
Caustic soda,
And
calcium
second one,
oxide.
calcium oxide, bleaching powder. Okay, what? How is caustic soda prepared?
Uh, Passing electricity to the concentrated aqueous solution by sodium chloride.
It's called electrolysis. What it gives?
NaOH plus
And
H2
two gas A and B. So this is
plus Cl.
compound X. This is compound X on electrolysis. You can write it like this way also. NaCl equals on electrolysis. When you pass electricity to it, it will gives you NaOH plus H2 plus Cl2. Got it?
Yes, sir.
Now this is compound X. This is NaCl. This is water. Understood?
Yes, sir.
So it is saying a compound X on electrolysis gives an strong gives a produce a strong base. This is a strong base. NaOH is a strong base. So this is compound Y and two gases A and B. Now the two gases A and B. Now it is saying B is used for manufacturing bleaching powder. So which gas is used for manufacturing bleaching powder?
Chloride.
Chlorine gas. So you have to write here B and this one is A. Write X, A, Y, and B. So X is NaCl, Y is NaOH, A is hydrogen, and B is chlorine gas. Now you understood?
Yes.
Note the answer, please.